Hello everyone. Today we are talking about the Grok Bankr exploit, where a public AI reply, Morse code, and a crypto wallet reportedly turned into a six-figure transfer. The tempting headline is, "Someone tricked Grok into sending money." But that is not quite the useful story. The useful story is that translated language was treated as financial authority. And once language can move money, every public message becomes part of the control surface. So first, let us rebuild what public reporting says actually happened, because the mechanism is the lesson. Bankr had provisioned a wallet associated with Grok on Base, connected to the DRB token story. An attacker reportedly sent a Bankr Club membership NFT to that wallet, and token-gated features can change what an agent workflow is allowed to do. Then the attacker posted an obfuscated message on X and pulled Grok into the thread. Grok did what a helpful model does. It decoded the Morse code into normal text. That decoded text included a command for Bankrbot to transfer 3 billion DRB tokens to an attacker-controlled address. Bankrbot treated the public decoded output as a valid instruction and executed the transaction. That is why the private key question is useful, but not central. This was not a classic wallet drain where someone breaks cryptography. Public reporting describes a trust chain. Untrusted social content went into Grok. Grok produced a clean-looking instruction. Bankrbot consumed that instruction as if it carried authority. Morse code was not powerful. The decoded sentence simply landed too close to execution. The Morse code detail still matters because it shows the deeper weakness. Morse code did not hack the wallet. It changed how the message looked to different readers. A human skimming the thread sees dots, dashes, noise, and maybe a puzzle. The model sees a normal translation task. The next agent sees a normal command. That is the dangerous asymmetry, harmless to the reviewer, executable to the agent. This is where the incident stops being only a crypto story. Rapello's analysis pointed out the transferable pattern, encoded payload, dropped guardrail, and agent-to-agent trust. The payload could be Morse code in a public post. It could be base 64 in a file, hidden Unicode in a pull request, or an HTML comment a reviewer never sees. The dropped guardrail matters too. Reporting says an earlier Bankr implementation blocked Grok-originated replies, but that protection did not survive a rewrite. That is the part every engineering team should recognize. A one-line defense that is not covered by a regression test is not a control. It is a hope. The same shape has already appeared around enterprise AI assistants. EchoLeak, the Microsoft 365 Copilot case study, showed how a crafted email could push an assistant across trust boundaries and exfiltrate data without the user clicking through the content. Google Gemini research around malicious calendar invites showed the same idea. External content can become instructions once an assistant reads it in the right context. With coding agents, the target can be a pull request, a CI job, an MCP tool response, or a repository file. Different surface, same question. Where does untrusted text become trusted action? That question matters because agents change the cost of being wrong. With a chatbot, a bad answer can mislead a person. With an agent, a bad answer can become an API call, database update, refund, deployment, trade, command, email, or payment. The model is no longer just generating content. It is sitting inside an operating loop, so the risk is not just prompt injection. The risk is prompt injection connected to authority. Security teams already have a name for the second half of that problem: excessive agency. OWASP describes excessive agency as too much functionality, permission, or autonomy around an LLM system. Too much functionality means the tool can do more than the task requires. Too much permission means a read workflow quietly has write power. Too much autonomy means the system can take high-impact action without independent approval. The Grok Bankr case is memorable because the action was money. The enterprise version could be customer data, cloud spend, access tokens, vendor payments, or production infrastructure. So the fix is not to tell the model to be more careful. The fix is to stop treating model output as authorization. Let the model interpret messy input. Then put deterministic policy between interpretation and execution. Decode before evaluation. Validate the source. Check the recipient. Cap the amount. Simulate the transaction. Require approval for new destinations. If anything is ambiguous, fail closed. The boring controls are the ones that would have changed the outcome. A recipient allowlist would have questioned the attacker wallet. A spin cap would have stopped a treasury sweep. A social trigger kill switch would have stopped public replies becoming commands. A regression test would have caught the missing Grok block after the rewrite. An out-of-band confirmation would have required a fresh human signal, not a sentence in a public thread. Here is the checklist I would use before giving any agent real power. What can it see? What can it change? Which inputs stay untrusted after decoding, summarizing, retrieving, or translating? What is the maximum damage from one wrong instruction? Can the system stop, roll back, or freeze before the cost becomes irreversible? If those answers are vague, the agent is a demo with a balance sheet attached. The lesson from the Grok exploit is not that agents are useless or that crypto is uniquely strange. The lesson is that connected agents make language operational. Once an agent has tools, the prompt is no longer just a prompt. It is a possible route to a side effect. Before giving an agent a wallet, inbox, database, browser, shell, or deployment key, ask one blunt question. If this agent misreads one message, what is the most expensive thing it can do before a human can stop it? That answer is your real risk model. Subscribe for more plain English investigations into AI systems, failures, and guardrails that matter.